Welcome to another episode of Microsoft 7687 exam preparatory course covering Windows 8.1 today. My name is Scott Neal and we are going to be covering Lesson 18, Configuring Security for Mobile Devices. Today's lecture is really about BitLocker. We're going to cover exam objective 5.3. We're going to look at special concerns of mobile security devices today. We're going to be kind of reviewing some things we've talked about in past lectures before we introduce BitLocker. Once we talk about some of the benefits of BitLocker, we're going to move into the requirements, the nuts and bolts of BitLocker and how it works. There are some prerequisites, some hardware prerequisites that we need to talk about, particularly when we talk about protecting the operating system files themselves using BitLocker, not just the data on the machine. Last but not least, we are going to introduce BitLocker To Go. That is BitLocker for our removable drives that will allow us not only to use BitLocker on those drives for our current device, but to be able to take that and use it on other devices as well. Prior to doing the demo for BitLocker, we'll talk a little bit about BitLocker during the demo and actually show you how we can use BitLocker to encrypt the device. So let's go ahead and get started. Obviously, mobile device usage has significantly increased in recent years, and with that have increased the security concerns surrounding the use of these devices. It wasn't that long ago that doctors carried patient data on flash drives, dozens, hundreds of patient records on a single flash drive. To them it was convenient and made their job a lot easier. It was considered accepted. Not unusual for us to carry our user data home with us as IT support personnel. Not uncommon for you to perhaps carry your customer data home as well on, say, a laptop or an external drive so that you can do work from home. We have seen, thanks largely in part to significant regulatory requirements in recent years, whether those requirements were HIPAA or FARPA or other local, state, and federal regulations governing the use of sensitive data on a network, we have seen some significant fundamental shifts of behavior as far as how we store sensitive data on mobile technology. So with that, we still, even with these fundamental behavioral shifts, it's not uncommon to have a laptop or a flash drive or external drive that does contain data that we perhaps would not be happy if it fell into other people's hands. Anyone who's had a laptop or any of these devices and after a long day of work, getting in the car, getting ready to head home, or maybe you sat down at your desk coming into work and looked around and realized that that smartphone wasn't with you at the present moment, certainly knows what I'm talking about, because that's certainly one of the things that you think about while you're looking for that device is, well, what's going to happen if someone stole it? Will they be able to get any information about me or my family? If you're working in a corporate setting or you're dealing with corporate devices, that issue is magnified tenfold for each device that you're responsible for in the corporate network. So we oftentimes talk about, as IT support personnel, about improving how we can manage security on these devices. In general, though, particularly for single users, there are two fundamental areas that we worry about the loss of data, one of which is over the wireless network. That's one reason why in earlier episodes we talked about the importance of connecting to secured wireless networks using the best encryption methods out there, AES encryption. And we also talked about, and I always advocate for the use of VPN where appropriate, virtual private networks, or even application layer encryption to ensure that not only is the data safe in transit, but it's also safe at rest on the server. Probably the largest, single most important security concern when it comes to mobile device security is theft or loss of the device itself. An estimated 10%, according to some folks, of all mobile devices will be lost or stolen during their lifetime. So it's important for us to think about and advocate for the use of strong passwords on these devices, to do whatever we can to ensure frequent backups of the data on these devices, even if that means backing up through some secure method to some sort of cloud storage apparatus. And of course, last but not least, using some sort of adequate device encryption method to ensure that the device itself cannot be compromised in some way. It is this last little tip that leads us into a discussion about BitLocker. Microsoft has wanted a piece of the mobile technology pie for some time now, and it's only natural that we would see some additional security features addressing mobile technology in Windows 8, 8.1, and even Windows 10. So BitLocker is one of those methods that we are seeing being implemented in Windows environments to help address some of these concerns. Now, we've talked about EFS also in past lectures, encrypted file systems. It's very good for protecting individual files or folders. And BitLocker is not meant to replace EFS. However, BitLocker does have some fundamental benefits. For one thing, instead of being able to protect simply a simple individual file or a folder, we can use BitLocker to actually enable encryption for an entire volume or drive. In past years, we've actually had to rely on third-party applications to accomplish this task. So it's nice to see that Windows is finally taking this whole volume encryption seriously. Now, BitLocker actually has been around since Windows 7, but in the Windows 8.1 release, we have seen some additional enhancements. For instance, now you can deploy BitLocker even before you install the operating system files, ensuring an additional layer of security even before the operating system is installed on the device itself. I can also encrypt not only the drive space currently being used, but I have the ability now to encrypt the entire drive, which is fundamentally more secure. And when I use BitLocker in conjunction with Server 2012 R2, I can employ the network unlock usability of BitLocker, providing an additional security and convenience for the BitLocker system. Now, using BitLocker does require you to enter a 4 to 20 digit PIN in order to start the system. And it's also important to note that BitLocker will support both hardware-based encryption through the use of TPM, and we'll talk about that momentarily, which provides a better source, a better way to use those resources. Or if you don't have a TPM on your device, you can go to the software-based encryption methods for BitLocker as well. Alright, so what are the requirements of BitLocker? Well, BitLocker does require Windows 8.1 Pro or Enterprise editions in order for it to work. In other words, you're not going to find this functionality on, say, Windows 8.1 Home Premium. You do have to be an administrator to configure BitLocker, though anyone can change the startup PIN by default once that BitLocker has been configured. Now, if you're an administrator, you may wish to disable that option. You can do that through the local or the domain group policy. Now, if you want to ensure that you are optimizing the security of BitLocker, it's best to use BitLocker in conjunction with what we call the Trusted Platform Module, or TPM. Now, the TPM is really a chip that is found on newer devices to help implement additional security functionality. It's not a requirement, but when you have TPM, you can use the TPM not only to ensure that the drive or the volume is encrypted, but I can also use BitLocker to verify the integrity of my boot files and my operating system. When you configure BitLocker for the first time, you are going to generate a startup key. Then you are also going to generate a recovery key, and that recovery key is a 48-digit number. It is only going to be used to unlock the system if BitLocker detects that tampering is detected. For example, if someone steals your laptop, they cannot get into the laptop and they try to circumvent the encryption by using another operating system to access that data. BitLocker will note that the operating system environment has changed and it will require a recovery key to unlock the data. Now the startup key can be stored on the TPM for convenience if you have one available on your device. If not, that's fine. You can use a USB drive. But remember, that USB drive will have to be kept with you and installed each and every time to decrypt the drive. If you store it on the TPM, the BIOS will retrieve that key automatically at startup, saving you a step. Now, what is a TPM? Well, as I said before, it is a chip that resides on the device itself, and you can determine if you have a TPM, if you're not sure about that particular device, by simply pressing the Windows logo key and R and then typing tpm.msc, bringing up the TPM snap-in. And if you have TPM, it will give you the specifications for the TPM. If not, you'll get a screen like you see here on our PowerPoint slide here. My device that I'm using for recording today's lecture does not have a TPM, and you'll see that when we do our demo. So let's talk a little bit about how we authenticate to the device with BitLocker. There are 5 ways we can do this. Let's talk about the most secure method, using TPM in conjunction with a startup pin and the startup key. When we use this method, the BitLocker encryption key will be stored on the TPM chip, but an administrator will need to insert a USB key containing the startup key and enter the correct pin to boot the system. You can also use a TPM and a startup key without using a startup pin. In this instance, the BitLocker encryption key will still be stored on the TPM chip, but you will only need to insert a USB key containing that startup key to boot to the system. I can do the same thing without the startup key, but using a startup pin. And if I don't have a TPM module on my machine, I can use a startup key only. This is great if I don't have a TPM, but it's a lot less secure than the previous 3 methods. The least secure only involves using the TPM. The BitLocker encryption key will be stored on the TPM chip and only verifies that the boot environment is going to be unmodified before automatically assessing it. Now, when encrypting the operating system drive using BitLocker, the startup key is going to need to reside on a separate piece of hardware. This could be your USB key or the TPM module, provided you're running version 1.2 or later. If BitLocker is enabled on a TPM system, the operating system integrity will be verified prior to booting to the operating system. If tampering is detected, the system will be locked and a recovery key will be required to gain access to the data and the operating system components. The following is required to encrypt the operating system drive. 2 partitions. One partition will have to be 100 megabytes or greater, and the second partition will serve as the encrypted operating system partition. You're going to have to run an NTFS file system because only NTFS will support the BitLocker components. And TPM compatible BIOS will be needed in order to support that bootable USB key. If I don't have a TPM chip on my device, say I'm using an older device but still want to incorporate BitLocker as part of my security plan, I can do that. In order to do that, I will have to be satisfied with the fact that BitLocker will not be able to verify the integrity of the system. When you enable BitLocker using the BitLocker Drive Encryption Control Panel, you on a non-TPM system, I am going to get an incompatibility error. And that is going to require me to make some alterations in my local or domain group policy in order to run the BitLocker configuration. I can do this pretty simply by going into the GPEdit snap-in, going into computer configuration, policies, administrative templates, Windows components, BitLocker Drive Encryption, operating system files, and choosing to check the Allow BitLocker Without Compatible TPM. Trust me, I'll show you this on the demo. BitLocker is great for securing the device components, but I can also use BitLocker To Go on removable drives, including secure digital cards, to enhance the security of those removable devices. Once configured, I can actually use NTFS or FAT16, 32, or even exFAT on those devices. Now, a password or the addition of a smart card is going to be needed to unlock that particular drive. I will insert the removable drive and open the BitLocker Drive Encryption Control Panel application just like I would if I was going to encrypt it, the hardware itself, and enable the Turn On BitLocker link. Now, I can also use domain group policy settings to modify BitLocker To Go behavior. Once again, that is under the Computer Configuration, Policies, Administrative Templates, Windows Components, BitLocker Drive Container, and under this particular instance, I'm going to choose Removable Data Drives. Okay, so let's summarize this lesson. Some security concerns of mobile devices include the theft of data. So it's important that we use encryption of the data to prevent unauthorized access, particularly in instances of theft. And unlike EFS, BitLocker is used in concert with TPM technology to protect not only a file or a group of folders, but the entire contents of the system, ensuring the integrity of the operating system environment and preventing evildoers from accessing the data through another operating system. BitLocker supports 5 authentication methods using different combinations of TPM, removable USB drives, and pins, each giving us a different level of security. BitLocker To Go will allow the encryption of removable drives that I can authenticate to on other systems, and I don't need a TPM to do that. And of course, BitLocker settings, just like many other settings in Windows 8.1, can be configured using the local domain or local group policy settings. So, let's look at the demo portion. Okay folks, welcome to the demo portion of Lesson 18 today, and today we're going to be enabling BitLocker for our operating system drive on our virtual machine. So we're going to start off in the control panel under System and Security. When we click on System and Security, we look for the BitLocker Drive Encryption. We click on that, we can see that BitLocker is turned off. Now you see when I turn on BitLocker, because we do not have a TPM option available for this virtual machine, we're going to have to go into the group policy and make some changes. So let's go ahead and do that. So we go into, we go into Run, GP Edit. We type GP Edit, and we're going to go into Computer Configuration, Administrative Templates, Windows Components. Let's spread this out. Okay. BitLocker Drive Encryption. Operating system drives, and we're going to look for something that says require additional authentication at startup. Okay, we're going to open that up. Now we're going to enable this option. We're going to select this Allow BitLocker Without Compatible TPM. This will require us to use a password on a startup key or on a USB flash drive in order for this to work. And we're going to save this option. Okay. Now that we've changed that GPO, we can go ahead and close out of all this, and we can turn on BitLocker. Okay. We're going to hit Next. And it says here an existing drive or unallocated free space on the hardware will be used to turn on BitLocker. We're going to hit next. And then we do a restart. Okay, now that we have prepared the drive for the BitLocker process, we need to encrypt the drive. Okay, we're going to enter a password. Okay, and we're going to say next. And we're going to have an option here. How do we want to back up that recovery key? We can save it to a Microsoft account, we can save it to a flash drive, we can save it to a file, or we can print the recovery key. So let's just print the recovery key. And we're just going to print it on here, print. Okay. Alright, we're going to hit next. And we're going to encrypt the use disk space only. This is faster. Not as secure, of course. And then we're going to run a BitLocker system check. And the encryption will begin after the computer restart. Alright, so now we can actually type in the password. Okay. And there you have it. We have successfully encrypted the data on our drive. Now bear in mind that we did choose the less secure option of just encrypting the used data. It is recommended to go ahead and encrypt the entire drive, of course. But for the sake of our demonstration, this was quicker and easier. And as you can see, we'll be allowed back into the operating system files. Obviously, if you have a TPM module on your laptop or on your desktop, you're going to want to take advantage of the additional features and being able to verify the boot integrity of your boot files and your operating system files as well. Okay, well that's it for the demonstration for lesson 18, and we will see you next time. Thanks a lot.